All right, this is a requested video about how we know if a local linearity gives an underestimate or an overestimate. Interrupted my dinner and just had my nice bottle of water. Go Tigers, Occidental. All right, here we go. What is local linearization? Let's just start there with a quick overview. Let's say that we just had a curve out in space. I'll give you some axes. Good for you. And remember that lines tangent to the curve really matter. So right here at this point, we'll call that A. All right, x equals A. This blue line is tangent to the red curve. We'll call that f of x at x equals A. Now, you know what? Just for numbers' sake, let's make that a 9. Haha. Very little I needed to change about that A. That was a very bad A. All right. When we are using local linearity, which is estimate the value of f of 9.1 using the line tangent to the curve, what we're really doing is we're finding, if we did 9.1, right? That'd be this value. We're finding this little dot that I just found here. But you might be able to see the true value of f of 9.1 is on the red curve. In this case, the estimate of 9.1 would be an underestimate, right? That would be the value of the line tangent to the curve at 9.1. Ooh. That's the concept. That's what we're doing here. Let me give you the rules in short. Right? Because concavity is linked to this. And if I try this again, here you might be able to tell f of x is concave up on this rough interval. If here we're concave down, all of a sudden, if I draw my line tangent to the curve, here, my points on the tangent line are above my true values. All right, so that's really what's going on here. But here's the rules. What's a good color for this? Blue is a good color for this. If f double prime of, we'll say A, is greater than 0, the line tangent to the curve at x equals A will give, I'll say give, I could have said give or yield or underestimates. Conversely, if f double prime of A is less than 0, automatically your head should pop into f of x is concave down at A, right? Second derivative is less than 0. The line tangent to the curve at x equals 9 will give overestimates. And that's the line tangent to the curve. So that means that if we were talking about estimating at 9.1 or 8.9, it doesn't matter if we're on the left or the right. Concavity is what matters, right? This is what matters. I'm going to show you this with numbers and such, just so that we're all on the same page. All right. let's say that we've done the work and we know we're trying to, let's just say I'm trying to go fast. So let's say we've done the work and we know that y equals 2x minus 3 plus 4 is tangent to the curve at x equals 3. The curve f of x. All right. First, like a part A might be, or a part A, or well, I don't know. Estimate the value of f of 3.1 using the line tangent to the curve at x equals 3. So in this case, we're already given this. Believe me, in my course, I am much more likely to make you do this, right? Make you give me this line. Keep in mind, whatever your line is, like finding the line and evaluating the estimate are different skills, so they will be graded separately. All that means is that if you come up with the wrong line, but you do the right work in this part, you will still get most of your points. All right, here we go. So all you would do here is y equals 2, 3.1 minus 3 plus 4. These all look very similar, right? 2.1 plus 4, 0.2 plus 4 equals 4.2. Ugh. And I'm just going to arbitrarily say for this part 2. So we're going to take that 4.2, we're going to throw it in the bank. This will be the part 2. We also know that f double prime of x equals negative x cubed plus 4x squared is your answer to the previous problem. An overestimate, or why are there such long words? Underestimate. Did I even spell that right? Is that even legible? Whatever. So now we have our estimate. Our estimate is 4.2. Whatever the hell that is doesn't matter. What does matter is that now we have the second derivative, and this second derivative is very simple. I came up with it just for this problem. But you're very likely on my big scary Unit 3 AP Calc test to have a second derivative that is enormously more complicated, but just so that we know the concept. All we're going to do is well, f double prime of 3 equals negative 3 cubed plus 4 times 3 squared, negative 27 plus, let's see, 4 times 9 equals 9. All right, so we find this, and now let's do the writing part. F double prime of 3 is greater than 0. And again, let's just bring this back. Oh, so now I just need to throw in the word underestimate. So 4.2 is an underestimate. Because here's what I'm looking for. All I'm looking for is the derivative evaluated at the point, and then this little sentence. This writing, and then saying, this value 4.2, which was, again, right or wrong, whatever number we found when we actually did the estimate. Maybe if I want to be perfect, of f of, what would we do? 3.1. All right, there you go.